The Olympic swimming pool in Munich. The joys of swimming in warm water. To ensure that the water remains clean and hygienic, some 700 cubic meters are pumped off each hour, cleaned and returned with fresh water to the swimming pool. In this way, the entire pool content is circulated 6 times a day. The circulating pumps are equipped with a mechanical seal. They can't be seen from the outside, but without them, things would begin to flounder. Mechanical seals from Burgmann. They can be relied on when it's cold, or at high temperatures, with high or low viscosity fluids. Mechanical seals operate at high and low speeds, at normal pressures and at extremely high pressures. Here, for example, we have a boiler feed pump in a power station. Mechanical seals are manufactured for virtually any application where a rotating shaft has to be sealed. This is what a mechanical seal looks like. But how does it work? A housing and a shaft. Fluid is stirred, pumped, centrifuged, or treated in some other way within the housing. It's the shaft that initiates the rotary motion. The gap between the housing and the shaft has to be sealed. That's obvious. But now the shaft will no longer turn. Rotation and sealing. Can they ever be compatible? Here, the shaft requires clearance so that it can rotate. Seal faces not parallel with, but rather perpendicular to the axis. That's the answer. The housing and the shaft boss form the seal faces. Good support is essential for the proper performance of the seal. But will the seal withstand higher loads? The seal starts leaking due to wear caused by friction. The shaft and housing are far too expensive to be used as wearing parts. Ideally, only the seal faces should be changed. A stationary seat at the housing, a seal face on the shaft. Exchangeable wearing parts make it possible to optimize the various available materials. Here, the seal is perfect. But here and here, we still have a leakage path. Of course, instead of one sealing gap, there are now 3. No wonder there's a drip. Because seal and seal face rotate at the same speed, they don't move in relation to each other. Between the housing and the stationary seal face, there is also no movement. And if nothing moves, sealing is no problem. Secondary seals are used. Wear cannot be totally excluded, but it can be compensated. With a spring, for example, which presses the sealing face to the stationary seat. Here we have it, the mechanical seal with its 5 components. Rotating seal face with secondary seal and spring. Stationary seat with secondary seal. Two rules must be observed to enable this principle to function. Even finely ground surfaces still have a certain degree of roughness. This roughness must be particularly small on surfaces that slide against each other. Consequently, stationary and rotating seal faces are not only ground, they are also lapped. Lapping gives the seal faces a higher bearing surface, thereby increasing the load capacity of the seal. The sliding faces must be absolutely flat and smooth with a mirror finish. That is the first rule. The second rule is the sliding surfaces must be perpendicular to the shaft axis. All this requires strict adherence to the permissible parallel run-out tolerance, stable shaft bearing support and careful assembly. Flatness and negligible surface roughness of the sliding faces are preconditions for minimal spacing between the seal faces, for the microscopically small sealing gap. Sealing gap? Sealing gap? A gap would fill up with fluid. A gap must surely result in leakage. Wait a moment. The seal faces slide on a thin fluid film. This fluid film is hair thin, so that the sliding faces hardly come into contact with each other. The fluid that is to be sealed simultaneously supplies the lubricating film for an optimal sliding motion of the seal faces. That's the answer. The sealing effect is either 100%, but then the seal faces will run dry and wear, or there's a lubricating film between the seal faces and minimal leakage will be unavoidable. But then a seal with a very low leakage rate will offer long service life and utmost reliability. This means the lubricating film is indispensable for the performance of a mechanical seal. It can be quite a problem for the lubricating film to maintain the balance, to remain stable, as there are several factors in practical operation that influence the stability of the lubricating film. The medium, pressure difference between inside and outside, high and low temperatures, high and extremely high speeds. The large number of different mechanical seal designs matches the influencing factors and their numerous combinations. Whether it's a specially designed or mass-produced mechanical seal, the range of application is indeed very wide. For shaft diameters between 5 and 500 millimeters. Sealing pressures from vacuum to pressures of 45 megapascals. Temperatures from -200 to +450 degrees centigrade. For sliding velocities of up to 150 meters per second. Mechanical seals from Burgmann.